Hello everyone, in this video we'll be solving problem 274 H index. The problem statement is we are given an array integer citations where citations of I is the number of citations a researcher received on their ith paper. We need to return the researcher's H index. According to Wikipedia, H index is defined as the maximum value of H such that the given researcher has published at least H papers that have each received a citation of H times. In example number 1, the H index is 3 that have received at least 3 citations. I hope you are able to understand the problem statement. There are multiple ways we can solve this problem. So let's switch to whiteboard and discuss the solution. One of the simplest approach to solve this problem is to use brute force, where we'll run multiple iterations to look for papers that match a certain H index. As there are a total of 5 entries in the input collection, the maximum H index can be 5. As we know the expected range of output, we can run an iteration with different combination of H index and look for the total number of papers in the input collection that matches that expectation. And during the iteration, we'll use a variable called counter, which will be incremented every time we stumble upon an entry whose citation value is greater than the expected H index. And as we are looking for the maximum H index and we are starting the loop with the highest possible value of H index, we can stop the iteration whenever we get a combination that we are looking for. And let's say we do not find a combination of papers that matches the required H index, we'll decrement the H index to 4 and retry. With this solution, our time complexity is O of n square as we are running multiple iterations on the input array with different combinations of H, while the space complexity is O of 1 as we are only using two variables. One is the counter to record the total number of citations and the other is the expected H index. As the time complexity of this approach is high, let's discuss a more optimized solution. Another way to solve this problem is to first sort the input array and then run the iteration. Once the array is sorted, we know that all of the elements to the right side of a particular element will always be greater than or equal to the current element value. And as we are looking for all of the papers that have a minimum of a certain citations, sorting the input array makes things very easy for us. Let's walk through a short example. With I is equal to 1, the corresponding value is 1. It means that paper received 1 citation. Now I know all of the elements to the right side of this element will at least have 1 citation for all of the papers. And because we know the total number of papers in the collection, we can easily calculate how many elements are there to the right side of I. By applying a simple math, we can easily calculate how many papers are there in the collection whose citation counts are greater than I. With 3 elements to the right side of I and including the current element itself, there are a total of 4 papers in the collection whose citation count is going to be greater than or equal to 1, that is I. Let's walk through one more example with I is equals to 2. Corresponding value is 3, which means all of the values or papers to the right side of 3 will have at least of 3 citations. As there are 2 elements to the right side of I and including the current element, there are a total of 3 papers. As the criteria for H index is met, we can return 3 as our output. As we are looking for the maximum H index, once the array is sorted, we can run a loop from left hand side towards the right hand side and use this condition to check for H index. And whenever the condition is suffice, and return the pointer value. With this solution, our time complexity is O of n log n, as we are first sorting the input array and then running an iteration to figure out or calculate the H index. And the space complexity is O of 1, as we are only using couple of variables to calculate the H index. As you can see, this approach is comparatively better than the previous approach. Now let's discuss a different approach where we can improve our time complexity even further while compromising on space complexity. In this approach, we'll introduce a new collection which will be used as counter to record the number of papers based on citations. The index of these elements will be equal to the number of citations the paper received. For example, if there are two papers with 3 citations in the new collection, at index 3, the value will be 2. Let's run a quick simulation on the input. With the first value as 3, we'll look up the corresponding index in the new collection and increment its value. Next element is 0, so we'll update its corresponding value as 0 in the new collection. The next value is 6. As you can see, we don't have 6 in the new collection. So instead of adding a new element with index 6, we can just group it under 5, saying that all values that are greater than or equal to 5 will be recorded under 5. As the H index is based on the number of papers and not the value of citations, the H index can never be anything greater than 5. So value of 5 will be incremented by 1. After that we have 1 and then 5. So 5 will be again incremented to 2, while index 1 will also be incremented. The next step is to count the number of papers based on the citations by running an iteration from right hand side to left hand side. Starting with the last element, the total number of papers are 2 and the citations are 5. As it does not meet the criteria for H index, we cannot return that as our output. So we move towards left by decrementing our pointer. The pointer is at 4 and the corresponding value is 0. It means for citation 4 there are 0 papers. But to calculate the total number of papers with at least 4 citations, we need to include all of the papers that have citations greater than 4, which includes sum of all of the values to its right. So the total number of papers with at least 4 citations are 0 plus 2, that is 2. As the condition is not suffice, we'll again move towards the left and repeat the same calculation. This time I is equals to 3 and the total number of papers with at least 3 citations includes 1 and all of the values to its right, which is 3. As the condition for H index is suffice, we can stop the iteration and return 3 as our output. With this solution, our time complexity is O of n as we ran multiple iterations, first to record all of the values in the given input based on the number of citations, and the other is to calculate the H index based on the index of each value and the corresponding citations. If we simplify the two iterations, the overall time complexity is O of n, while our space complexity is O of n as well, as we created this additional collection to record the count of each paper's corresponding citations. I hope you were able to understand all the three explanations that we just went through. Let me show you how we can implement this particular solution in C#. Here is the C# solution. In the main method, I start by initializing a counts variable to record all of the counts of the corresponding paper citations. After that, I am starting a for loop to fill all of the values in the counts variable based on the paper citations. Once the collection is populated, I am starting another for loop on the counts variable that we just created, calculate the total number of citations based on the value, and then comparing it against the index I. If the total citations is greater than or equal to I, it means we found an H index, so we can return I as our output. If no, then we continue with the for loop. During the for loop, if we do not see any scenario where the H index criteria is met, we jump out of the for loop and return 0 as our output. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and 83% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. For details to access the source code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.